myself Rajas Lambe from the College of Engineering and Research. I am currently pursuing 7th semester in Electronics and Telecommunication. I am a part of this internship conducted by Emertxe Information Technologies. The table of content for this internship were introduction to this internship, overview of internship, embedded C learning, embedded system learning, project and project demonstration. Introduction. In the modern world, household appliances play a virtual role in simplifying daily tasks, minimizing physical efforts, and improving overall productivity. Technological progress, especially the use of microcontroller, has transformed washing machine into smart, energy-efficient, easy-to-use machines. Washing machine project based on PIC16F microcontroller reflect the innovation and goal of developing a smart, adaptable, efficient washing machine system. Overview of internship. The internship was conducted by Emertxe Information Technology. This company was built on open source Linux platform. Emertxe system online courses and IoT courses provide an immersive learning experience for participants. Duration of internship was of 1 month from 13th May to 18th June. Mode of conduct was online. Skill developed. Proficient in embedded C programming. Understood microcontroller architecture. Learned to interface peripherals with microcontroller. Gained experience in debugging, simulation, real-time implementation. Improved logical thinking and modular thinking. Embedded C. In this internship, our first goal was to learn basics of embedded C. Embedded C is a general purpose language that was originally developed by Dennis Emertxe by to develop Unix operating system. Embedded C is a system of language extension for C, designed to program microcontroller and embedded systems. In this internship, we also learned about embedded C for programming our microcontrollers like PIC, LPM, and others. It can include special features like direct access to hardware register, input-output ports, memory locations, using specific keywords. Embedded C allows writing efficient, real-time hardware interfacing, code to control devices like sensors, motors, LEDs, and more. It provides fine-grained control over hardware, making it highly efficient. As a result, C is commonly used to develop system-level programs, like designing operating systems. We also learned C in this internship. The main purpose of learning C was to write embedded C programs that can be used for controlling and developing washing machines. In embedded C, we learn about keywords. Keywords are some additional data types. There are some sort of functions that can in embedded C which can be used for triggering special function registers and memory locations. Embedded C allows us to work with hardware devices like sensors and input-output devices. Data representation. Fundamental data types in embedded C are integer types, character, integer, short, long. Their size and range are vary depending on the architecture. Floating points. Float double used for representing real numbers with fractional parts. Void types represents absence of type, commonly used for pointers. String. String is a common programming. It is a sequence of characters terminated with null character 0. The string character is stored as an array of characters. The difference between a character array and string is that string C is terminated with unique character. Function. Function is a block of code which only runs when it is called. You can pass data known as parameters into functions. Functions are used to perform certain actions and they are imported for reusing code. defining the code once and use it many times. There are also conditional statements in C. There are two types of conditions in C: if-else statements and switch statements. In if-else statements, there are only ifs, if-else, else-if, and nested if. Also, in switch statements, we can break the switch statement using cases and breaks. Now, next part is embedded systems. Embedded systems was the major part of our electronic embedded system internship. This internship we majorly studied on embedded systems, how to control it, how to program it, etc. Embedded system is the combination of hardware and software, and it is generally known as firmware, which is embedded system into system hardware. Embedded C is used to program a wide range of microprocessors. Embedded C requires less number of resources to execute in comparison with high-level languages such as assembly, programming language. Embedded C allows us to work with hardware devices like sensors, input-output devices. There are various embedded C compilers to compile embedded programming, such as KD compiler, SPJ compiler, embedded GNU-C compiler. An embedded system is a combination of hardware and software designed to perform specific tasks efficiently. Embedded systems are focused for control, automation, and performance. Unlike high-purpose computers, embedded systems are task-specifically high optimized for performance, cost, size. No human intervention or very less human intervention is required. In this internship, the major part of our embedded system were to study of microcontroller and microprocessors. We learned about architecture of microcontroller, the difference between microcontroller and microprocessor, how microcontroller works, etc. Microcontroller is a compact integrated circuit designed to govern a specific operation in embedded system. A typical microcontroller includes a processor, memory, and input-output peripherals on a single chip. It is a computer on chip. It contains all elements of computer such as electronics, memory, input-output interfaces, and microcontroller processors. This provides small size, reduced power consumption, and ability of control processes or inputs. Microprocessors. Microprocessor is a programmable device that takes input from performs some arithmetic or logical operations over it and produces a desired output. In simple words, microprocessor is a digital device on a chip that can fetch instructions from memory, decode and execute text, and give return. It is an important part of computer architecture, without which you will not be able to perform anything on your computer. This is the major part of our internship. Now project overview. The purpose of our internship was to build a simulation of washing machine using PICsimlab, aiming to replicate real-world washing machine facilitate functionality in virtual environment. The project begins a comprehensive understanding of washing machine components, cycle and operations. Parameters defining laundry status such as fabric type, load size and water level are identified. Scope of this project was: this simulation project provides a valuable insight into washing machine operations, control system design and simulation techniques. Participants gain practical experience in developing algorithms to simulate intelligent applications, contributing to better understanding of laundry automation techniques. The components of our project were the main component of our project was PIC16F877A microcontroller. We used PIC16F877A microcontroller. The PIC16F microcontroller is frequently used in educational settings to teach microcontroller programming and embedded system design. Its accessible architecture and wide range of documentation make it ideal choice for students and educators. Peripheral interface control is one of the advanced microcontrollers developed by microchip technology. These microcontrollers are widely used in modern electronic applications. Microcontroller PIC16F is one of the PIC microfamily microcontroller which is popular at this moment. Start from beginning until all professionals use this microcontroller because of very easy to use and has flash memory technology so that can be write erase until 1000 times. Its superiority in this with microcontroller is compared with another microcontroller makes it more accessible and easy to use. Interrupts. In this project we are going to use interrupts. It is a signal which makes the processor to stop its current task and proceed to execute handler set for interrupting sources. There are multiple types of interrupt sources, external or internal, and based on the source we can classify interrupt types, maskable or non-maskable. Maskable interrupts can be avoided, but non-maskable interrupts cannot be avoided. Timers. Timers are the major part of our project. We are going to use timers in different ways in this project to help our project work smoothly. Timers in PICsimlab are three independent timers which can be used as timers, counters or PWM generators. Keypads. Keypads are used to give input by the user in binary format. They consist of push buttons. They can be triggered in two different ways, level triggered, edge triggered. They come in two different configurations also, source circuits and sync circuits. CLCD. CLCD or dot matrix liquid crystal display can interface with 4 or 8-bit microprocessors. It is an alphanumerical LCD display module operating, meaning it can display alphabets and numericals. It consists of 4 rows and each row can print 16 characters. It can work in both 8 and 4-bit mode. The CLCD in washing machine is used for displaying the current status of washing machine. So now this is our project block diagram. On the left side we get all our input which we are going to give to our microcontroller to control the whole process. First one, power on. Using switch 5 on the digital keyboard, we will give microcontroller to power on. Using switch 6 key on microcontroller, we can pause or stop the process that are currently going on in microcontroller. Using switch 4, we can navigate through our entire program, and using switch 1, it is a real life simulation of washing machine. As a result, the door opening status which we are going to include in this program is used or it is demonstrated using switch 1. On the right side, we have all our output devices like display, buzzer and monitor. Display, we are going to show all our operations and working in display. Buzzer and motor represents the working and end of the cycle of washing machine. In this project, we are going to use software called MPlab X ID. MPlab X ID is a free integrated toolset for development of embedded applications on microchip, PIC and DSP microcontrollers. It is called Integrated Development Environment or IDE because it provides a single integrated environment to develop code for embedded microcontrollers. X8 compiler. X8 is a popular C compiler developed by Microchip Technologies specifically for their PIC microcontroller. It is used to compile C code into machine code that can be executed in PIC microcontroller. X8 supports a wide range of PIC microcontroller and offers optimization for efficient code generation. Project Simulator. It is one of the major part of our project. Using this simulator, we are going to simulate a real-life working washing machine. The simulator we are going to use in this project is PICsimlab. PICsimlab is a real-time simulator for development code with integrated MPlab X or AVR GDB debugger. PICsimlab supports some PICsim microcontrollers and some SimAVR microcontrollers. PICsimlab have integrations with MPlab X or Arduino IDE for programming the board microcontrollers. It is very efficient and easy to use software which will be available on any website. Code. This is the small code snippet that I was working on during building this microcontroller project. Conclusion. The washing machine simulation using PICsimlab serves as an effective tool for learning and applying concepts of embedded systems. It offers hands-on experience that complement theoretical knowledge and provide a foundation for further exploration in field of automation and control systems. This project successfully demonstrates the design and simulation of washing machine using a PIC16F877A microcontroller. Key embedded principles that we used during this internship: control real-time process using timers and interrupts, interface hardware peripherals like keypad, LCD, buzzer, and fan. Provide a user-friendly interface with mode selection, water level configuration, and process filters. Thank you for allowing me to present my project. Thank you.